This is the second video in the Nixie clock series, which I'm currently constructing on prototyping boards and so forth. This video will concentrate on the Nixie driver board to the left and the Micromite control board to the right. If we just have a look at the Nixie driver board, the bottom three chips are the 74141 high voltage driver chips that are able to drive the 170 volts that the neon Nixie display requires. 74141 chips of top left and top right, bringing to a total of 5 chips to drive 5 of the tubes. The hours tube is either 0, 1 or 2, so we only have to display 1 or 2, and those are the 2 white dots which are the top of the high voltage transistor between beneath the 2 yellow squares. The 2 yellow squares are small high voltage converter boards that convert 5 volts supply to 170 volt high voltage for the Nixie tubes, and each one will drive 3 Nixie tubes, so that's why there's 2. The 3 chips in the middle of the board are the I2C bus to parallel the 8574, which I'm also using for my seconds indicator, which I've covered in the previous video. At the top of the picture is the cable coming in, which has plus and minus 5 volts and I2C clock and data, and the orange and white cable is another 5 volt supply, which supplies the high voltage converters. I'm just powering it off a different circuit at the moment, just for debugging, so that I know there's no power supply problems driving the logic and the voltage multipliers at the moment. So the 3 I2C chips in the middle, each one will output 1 byte. These 74141 converters need a half a byte, a nibble, and they do binary coded decimal off that nibble. So therefore 2 of those chips can be driven off 1 I2C chip. So therefore there's 3 I2C chips to drive effectively all 6 Nixie tubes. So that's pretty straightforward. The only eventually there'll just be plus and minus 5 volts and clock and data coming into that board, and that's it. Looking now at the Micromite board, top left is the blue real-time clock calendar board. I'm a fan of just buying these little boards for cheap from eBay. I'll buy 3 at a time, and one's probably doesn't work, and the other 2 I'll have as to use and for a spare. This is a clock calendar chip that's got battery backup, although eventually I'll probably put a supercapacitor on for battery backup, and it's accurate to a few minutes a year, and takes into account leap years and everything else on the calendar. Just a great little chip. That runs on the I2C bus, the same bus as the display board, although obviously at a different address. And the other things you can see on the board are the Micromite chip, which is a PIC32 series chip, the fantastic Micromite system from Jeff Graham. All that needs is the yellow capacitor beneath it, and you've got a full system. It's got a complete basic interpreter on chip, which I'll go into in a minute, and it executes about, I think, 30,000 lines a second, and it's got enough program memory for about 2,500 lines of basic. The basic is specially written for these sort of applications, and it has lots of functions built in for reading temperature chips, driving LCD displays, and particularly good, it'll drive big format, colour, touch sensitive LCD displays as well, just native to all of its commands. Just fantastic system. Very little else on the board at the moment. I will be hanging a lot more stuff off it, such as temperature sensors, humidity sensors, an LCD plug-in bottom right, and there'll be a microwave movement detector, so that the Nixie display is only turned on when people are nearby, and there'll be rotary encoder switch for setting the time, and so on and so forth. All of these things are very easily dealt with by the Micromite system. Not much more to say about that board, I think. This plug here is the programming plug from the computer, from the PC, and that's just a cheap USB to serial adapter, and there's a couple of pins reserved on the PIC for that, so you've got real-time communication back and forth from the Micromite to the computer terminal. So far, the real-time clock, the 60 neon seconds display, and the 6-digit Nixie tube display is taking a total of 2 pins of the Micromite on the I2C bus. Let's just have a look how the Micromite works. All of the I2C logic, all of the timekeeping, and everything you've seen to drive the display, which I'll turn on in a minute, is done with this code. That is it. It's looked really blurred actually, but you can see how little code there is to do all of that on the Micromite. Just excellent. And we just press programs the Micromite, and if I switch on, there's the time, and it all just works beautifully. I must admit, in various projects I've done with the Micromite, it's very, very robust, very reliable, and just works, just does things effortlessly. It's got a great command set, great version of the basic language, and the chip programmed costs $8 and everything's free. This screen editor is Edit, which is by Tazzy Jim, and it's free as well. It's just download it, go to the back shed, and where there's quite a good forum for everything Micromite, and just download it. Just fantastic. So that's it for the simple Nixie clock. Can't imagine it can be done a lot simpler than that, but anyway, that's all for now.